Please welcome Callum Benson, Monash University.
Hi, I'm Callum Benson. I'm very pleased to introduce you to our nominee company, Kite Magnetics. Built on the world-leading research from Prof. Kironori Suzuki and his talented team of materials science researchers, their patented technology uses novel nanocrystalline soft magnetic materials to reduce energy requirements for electric motors. Kite Magnetics is fundamentally re-engineering the industry's electric motors and generators for aircraft, and will create a new age of electric aviation that is safer, quieter, significantly cheaper, and emissions-free. This breakthrough technology was spun out of Monash in 2022 and has since been going from strength to strength. Monash is proudly the largest university in Australia and a top 50 ranked leading global research university, known for innovation and entrepreneurship. Here to tell you more about Kite Magnetics, their technology, and bold vision for the future is their CEO, Dr. Richard Parsons, who has taken on the journey of leading this technology from lab to market, having developed it during his PhD at Monash.
Breaking the wall to emissions-free electric aviation. Richard Parsons, Kite Magnetics.
1 billion tonnes. This is the amount of CO2 emitted by the aviation industry every single year. It's a number that's rapidly growing, so much so that by 2050, it's estimated that 1/4, 25%, of all emissions worldwide will come from the way that we all fly. For this reason, aviation must go electric. Already today, early pioneers have designed, built and flown 9-seat regional electric aircraft, 50-seat hydrogen-powered regional electric aircraft, and companies like Airbus are developing concepts for a 100-seat regional electric aircraft. However, all these aircraft suffer from one single fatal flaw. They simply cannot fly far enough due to the limitations of today's propulsion technologies. For example, here in Berlin, in the heart of Europe, the next generation of hydrogen-powered 50-seat aircraft will have a range of around 500 kilometres. This puts major city centres just out of reach. If we can't solve this challenge, then we're at risk of having to change fundamentally how we fly, either giving up flying altogether or potentially paying first-class ticket prices for economy-class seats as we adopt more expensive sustainable aviation fuel. Kite Magnetics is an aerospace manufacturing company using a newly developed magnetic materials technology to produce smaller, lighter, and more efficient electric motors for electric aircraft. Using our technology, we enable electric aircraft to fly up to 30% further, enabling Berlin to access 10 million additional potential fare-paying customers. We stand to reduce the cost of operating electric aircraft by millions of dollars per year per aircraft, and also reduce the number of required hydrogen refuelling stations across the world. This is a story that's not just true for Berlin, but for hundreds, maybe even thousands of other cities. And it's a benefit that grows year on year as other technologies enable electric aircraft to fly further. Enabling Kite Magnetics' electric motors to be lighter and more efficient is Aeroperm, a novel magnetic materials technology that has an energy loss 10 times smaller thanks to its amazing microstructure. This enables us to make electric motors at half the weight and 5% more efficient. Despite being an early stage company, only a year old, we've already developed our first product, a 120 kilowatt electric engine for 2 to 4 seat training aircraft, enabling the next generation of pilots to train emissions-free. Making this possible is a small but highly dedicated team of engineers, a team of 10 today. Myself, I come from a background as a materials engineer, developing high-performance magnetic materials for electric motors. We're guided by industry experts, veterans from the aviation space, who developed jet engines and seen them through the design, certification, production process. We're advised by experienced startup founders who themselves have gone through that rapid scale-up journey for their own hardware companies. We're backed by Investable, Possible Ventures, and Breakthrough Victoria, the Victorian state government's $2 billion sovereign wealth fund. And of course, we're supported by our partners, which, with their help, next year will begin experimental test flights for our first products as we head towards getting the validated data we need for commercial scale contracts. In the future, starting next year, we're going to go bigger. We're going to be developing a multi-100 kilowatt electric engine using aeroperm for 9 to 19 seat regional aircraft, allowing regional communities to connect with emissions-free, quiet, safe aviation. But long-term, our ambitions are far bigger. We want to develop, in the coming years, multi-megawatt electric engines using aeroperm. We want to partner with companies like Airbus and Boeing as they develop their own 100-seat plus hydrogen-powered electric aircraft. Our mission is to become a global OEM supplier of aircraft engines into the $90 billion aircraft engine market, wanting to stand shoulder to shoulder with existing industry companies like Pratt & Whitney, Rolls-Royce and GE Aviation. But ultimately, my vision, my hope, my dream is that one day all of us can go to a local airport or an international airport, board a plane, and as we're taking off into the sky on an emissions-free, quiet, safe, sustainable aircraft, look out the window and see a Kite Magnetics logo and a Kite Magnetics engine hanging beneath the wing. Thank you for your attention.
Thank you, Richard. Okay, let's go with the 4 minutes questions. We have one question here. You are with the first block here, right? I mean, they know the trick now. That's great. Okay, we will have also the... Okay, one, two, three, four. Let's go.
So reducing the weight of the motor, I understand, is one of the key things here. How does that relate to the weight of the battery? How much of an impact can that have relative to our need to improve energy density with batteries?
So definitely batteries are a significant challenge for aircraft today. They're too heavy. Fundamentally, it's going to be hydrogen that's going to be powering us on longer flights. What we do at Kite Magnetics is we use this new materials technology to make the motors more efficient. So the energy you do have, be it battery or hydrogen, gets you further. But also, equally importantly, this technology enables the motors to produce less waste heat. And it's the waste heat that fundamentally drives the power density of these motors, because you have to pull that heat out. And so by making less heat to begin with, the cooling system's lighter, the motor's lighter, more efficient, you fly a lot further.
Okay, thank you. Next question, please.
Quite challenging project here. Does the industry have...
We need a new microphone, sorry. Can we have a new microphone? Thank you. Let's go.
Does the industry is interested in your project?
Is the aviation industry interested in our project?
And you have still cooperations with them?
Yes, definitely. So we're speaking with, let's say, household name airframers and other large OEM companies who are interested in this technology, not just for the aerospace sector. We see the aerospace sector as our beachhead market, where we can mature the technology, we can grow the economy of scale, but ultimately, this is just the beginning. The dream is that we'll see this technology in high-performance electric vehicles, in consumer goods, industrial motors. Today, 50% of all the electricity we produce is consumed in an electric motor at some point. And so even single-digit improvements in efficiency across the world has a huge impact.
Great. Stefan, the next one.
Fascinating. What about the cost of production of this nanocrystalline material? That's not so easy, and how to bring it into the motor? And what's the cost difference compared to a regular motor? What do you imagine? And if I may ask, also the resilience at higher temperature of the material.
Good questions. There's no way around it. This is a new technology that is not scalable today like existing materials. I like to view it as sort of like the carbon fibre of the magnetic materials world. High performance, but high cost. You don't find carbon fibre in your toaster, but you do find it in your sports car. And the same is going to be true for aeroperm. It's going to find applications in high performance spaces. In terms of cost, today it is significantly more expensive, many multiples more so than the existing materials. However, with time, further development and economy of scale, we think we can bring that cost down. And ultimately, it could be that while it won't be price parity, it won't be 10 times more. It might be a few times more than existing materials.
Okay, we have another question here, please. Here, first row? No? Oh, okay, good. Well, then in that case, we would jump to the gentleman back then who is trying for at least 3 rounds to put a question. Thank you.
Thanks. Quick question. Is your aerofoam using rare earths or earth abundant materials, because that could be a very limiting factor for supply chain?
Yes, 30 seconds to go.
Thankfully, we do not use any rare earth materials in our magnetic material. So there's two types of magnets. There's permanent magnets like you get on your fridge, and your neodymium-based magnets, they do use rare earths. We're a material that's by weight mostly iron, abundant, cheap, plentiful. It's the way that this material is processed using a very unique casting process where you actually quench it at 1,000,000 degrees per second to form a foil. That gives it a unique microstructure and therefore its unique magnetic properties that make all of this possible.
Thank you. That's it. 1 second, 0. Thank you.
Thank you.
Soft landing. Please go.